To reconstruct accidents in which a vehicle vaults into the air after hitting obstruction, the model, we've got this long model here, can be used. V sub 0 is the velocity in feet per second of the vehicle when it hits the obstruction. D is the distance in feet from the obstruction landing point, and H is the difference in height in feet between the landing point and the takeoff point. Angle theta is the takeoff angle, and the angle between the horizontal and the path of the vehicle. Find theta to the nearest degree if, and they've given us this. What I'm first going to do here is I'm going to put in what they gave us. So V sub 0 here. Okay, so this is 60. If I can get this to go, and this is squared down here. Oh, it doesn't want to go in. Come on. There, so this is 60, and then it is squared. Oh, it does not want me to do this. Okay, well, we're going to remember. We're going to put, there we go. There's a squared there. Okay, and then here, this also, if I can get this to 80 squared. I give up on it's working. And then H, okay, so this over here. Okay, so then let's see here, my H. I don't even know what it's doing here. Where's my cursor? There, H is 2, and then D. Come on, D. There we go, D is 80. Okay, so that was way too much work than it should have been. So I'm going to start simplifying this. So 0.342 times 80. Okay, so this is 20. Okay, 27.36 cosine theta plus 2 cosine squared theta. Then over here, what do we got here? Let's work this out. So I have 80 squared times 16 divided by 60 squared, which gives me 24.4. Change that back to a fraction. So this gives me 256 ninths, which probably I didn't need to do, but that's okay. And then what I'm going to do here is I look at this and go, this is a factoring problem. So I'm going to rewrite a little bit just to go, and I probably will at this point decide to use so there's a 2 out there, and then plus 27.36 cosine theta minus, and this was 28.4 because I moved it over here, equals 0. The reason I did that is now I can plug in to my quadratic, negative 27.36 plus or minus 27.36 squared minus 4ac over 2a. Okay, now I'm going to get out my calculator and I'm going to do the math here. So I'm going to first I'm going to figure out what's under here. So I'm going to do 27.36 squared plus, because the two negatives cancel each other out, 8 times 28.44. I'll give it some 4s. Okay, so under there I have, so this whole thing is 976.1216. Because I'm going to need to do it twice, and I just didn't want to have to carry it through. Okay, so I'm going to start by going square root of this, okay? And I'm going to do negative 27.36 plus that divided by 4. So this gives me that cosine theta equals 0.97. Okay, now I'm going to go back and I'm going to try the other one. So I'm going to get negative 27.36 minus the square root of 976.1216 divided by 4. Now this gives me that cosine theta equals negative 14.7. Hopefully you look at that and go, nah, cosine can't be that. Cosine goes from 1 to negative 1, so I don't even need to worry about this. So I'm just going to do the arc cosine of 0.97, and I get approximately 14 degrees. And obviously here cosine is only positive in the first and fourth quadrants. I don't have to worry about stuff at 280 degrees. So this is theta equals 14 degrees. So that's my takeoff angle. So you can see here as we're working through this, we did get 2 answers, but we looked at one and went, well, that doesn't. Now, of course, how do you not realize that? Remember, your calculator will yell at you. If I put in the arc cosine of negative 14.7, it's going to go, nope, 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 nope. Okay, so it will yell at you if you don't realize that before you even try it. But this is how you do this problem, and you can see this is mainly just, a lot of algebra. I put in all the numbers, I crunched them all out, I put them into that quadratic, which then I ran through my calculator. I only used a little bit of trig there at the very end. But it's important, obviously, that we're very careful with all that algebra as we go through it.